Hello everyone, my name is Rohit. I'm an engineering manager at Meta, managing Presto interactive teams. I have been with Meta and Presto for 5+ years, starting as an engineer and then managing for last 1.5 years. Making Presto faster and leveraging it to make metadata analytics most productive in the world is a passion for me. Feel very excited to share all the amazing work happening in the Presto and the interactive warehouse in the Meta. With that, let's get into it. In my talk today, I will mostly be focusing on the interactivity stack in the data infrastructure at Meta. We would be talking about how Presto is playing a critical role with various data analytics functionality at Meta. We would be talking about how agentic exploration, especially with all the advancement in the AI world, is reshaping the products and the infrastructure. We would be talking about how we are building with warehouse with the focus on the interactivity to serve various critical interactive use cases served in the Meta. We would be speaking about how we are innovating to achieve consistent and low latencies for various use cases. Lastly, we will also be touching a little bit on the real-time metrics, which Presto is serving and how they are different and the challenges associated with it. With that, let's get into it. Cool. I think you are all familiar with the Presto and the role it is playing in the Meta, especially in the data infrastructure stack. But I wanted to reiterate a couple of things. At Meta, Presto is playing like a huge role in serving two kinds of critical use cases, batch and interactive. Batch is solving hyperscale challenges. It is mostly running asynchronously and in the background with a massive machine footprint. It is processing like exabytes of data on regular and everyday basis. On the other way around, like the interactive is about the human scale, right? More often than not, there is a human waiting for the results when leveraging this stack. So it is very critical from the employee productivity perspective, and it is having like a huge impact on everyday people workflows. So Presto is at the center of the business, while Presto is helping along with Spark to serve batch use cases. On the interactive side, it is exclusively responsible for all the interactive needs at the Meta. Let's talk about some of the scale. These are in approximations. So Presto is serving tens of thousands of analytics users on monthly basis. It is serving tens of thousands of dashboards and dashboard users. It is serving millions of queries on everyday basis, and it is processing and churning like petabytes, hundreds of petabytes of data on everyday basis. So it is serving lots of use cases and having a lots of scale and challenges in order to make the interactivity successful at Meta. Let's talk about some of the critical use cases which are served in Meta. So first is the traditional analytics users like data engineers, data scientists, right? Uh, or any software engineers which are basically leveraging various products available to do various kind of analytics by leveraging Presto. The second is the data applications. There are lots of data applications built on top of Presto in Meta with traditional dashboarding and exploratory analytics application to CRM solutions, which is powering our sales organizations and vast majority of our employees or contractors in the company to leverage Presto directly. It is helping saving huge number of sales hours, which has been very impactful. Machine learning engineers using various notebooks to do various kind of exploratory analytics. Then there are massive platforms built on top of Presto, such as experimentational platform. Meta is very data-driven company. And pretty much every single engineer leverages experimentation platform for any kind of development flow. And this experimentational platform is primarily powered by Presto and leveraging Presto computations at a massive scale. AI recommendation systems, collections of use cases and products working on ranking and recommendation system, which uses Presto for data preparation or analysis stages. Um, privacy system. Lots of privacy products are leveraging Presto to enhance queries with privacy compliance logic. Presto is a critical dependency for them to make sure all the data access remains privacy compliant. So in a nutshell, like the Presto remains like a critical part of various use cases. It is operating at massive scale. It is keeping most of the companies productive every single day, and etc. Now, along with all the use cases which are being served by Presto, another critical use case is growing day by day with all the advancement in the AI is agentic exploration. So what is agentic exploration? Agentic exploration in the data analytics refers to AI agents that autonomously explore, analyze, and interpret data with minimal to no human intervention. With the advancement in the AI capabilities, the way people interact with data and doing data analytics is changing. The landscape is evolving very fast, from manual processes to intelligent and proactive systems driven by agentic exploration. The shift is transforming not just how we analyze the data, but who and what does the analysis. So if we see the cycle of different stages, first we can see like the user used to do manual analysis on the data by writing and handcrafting these queries and executing queries to get various data or analysis. Then AI started playing a role in providing assistance to the user in different product services. These tools did not do the work for you, but they made it easier and faster. The way to is like how the examples there is like maybe you can maybe these tools are helping the users to build query completion, right? Or with the debuggabilities and fixing the queries. So the way to think about the analyst, the way to think about is that the analyst is still in the driver's seat, but now with the better tooling or gear. The next stage is the automated stage. So in this, the routine task becomes hand-free. These can be predefined tasks without human intervention. Now they can be rule-based or schedule-based, etc. In the next stage, which is the proactive analysis, these agents don't just wait. They seek out patterns, ask questions, and recommend actions. It autonomously generates various hypotheses, queries the data, and validate the assumptions. So if the one conclusion from this use case is that the landscape with AI is changing how data exploration works. And it is also changing the requirements for infrastructures with the kind of requirements it would have. So let's understand how. So from the data infrastructure perspective, the challenges are in the three categories. First, the discovery part about how the tables or the data sets or the data the agent can work with can be discovered. Then, how to use those data sets slash tables to generate various queries or logics. Then leveraging these query execution engines, Presto, to execute these queries. So let's go into a little bit details on each of these categories. First, discovery. So if agent needs to discover lots of data or metadata, the amount of data available in the meta is huge, right? So its ability to do it quickly is going to be crucial, right? So how we can help agents to do this quickly? Uh, First, by providing various ways or mechanism to do the fast and efficient mechanism to access the metadata so that the agents can understand more about the tables easily, right? By providing the semantic information about these tables to you to the agents easily. Now it can be done via standard table metadata available and making it faster, but it can also be done about it can also be done via generating like the semantic information and like auxiliary metadata along with these tables. We would also need to build fast and efficient sampling so that the agent can do a quick peek into the data to understand more about it. Some of these information may not be sufficient from the metadata perspective. So having the ability to do the quick analysis on the data itself is going to be really, really crucial, right? So that that can help agents to either accept or reject these data sets before running expensive queries. So once the agents have the data sets it want to work with, the next stage is going to be the query authoring. So agents would like to generate these queries and then quickly validate these queries from correctness and privacy perspective. It would also like to get real-time feedback on the generated queries before running these expensive queries. Now the next most important stage is the query execution. Agent queries need to be fast. They need to have reliable low latencies. Since the agents may try out various options, it may run into the case of firing lots of queries. So query volumes becomes a challenge. Query batching becomes a thing to look into it along with making query efficiencies. The other critical part of the query execution is the agent queries. Um, in comparison to the handcrafted queries by humans, these queries generated by agents may be suboptimal, both in terms of query shapes and with the data set it's working with. Agents at this point is less likely to create local data copies before executing queries, so it may run into the various inefficient scenarios. Lots and lots of challenges in this domain, but very excited about the possibilities it unlocks and the value it provides to for the various use cases. Now let's take a step back and understand all the work which has happened in the interactive warehouse space and how it is helping to provide low latencies for various use cases, not just the agentic exploration, right? So what is the interactive warehouse? Interactive warehouse is basically all the warehouse or data infrastructure, but built for the interactivity. In each of the critical components of the warehouse, we have been innovating to provide interactive experience to the user. Let's understand each of these components and the work happening. Metastore. Metastore is a critical component which Presto and other product ecosystem relies on to fetch various metadata about tables and the partitions. Over the last half or so, we have made tremendous improvements to the various metadata operations. Some of the notable improvements have been around various regions, replicas to save on the network latencies, or smart filters processing to optimize expensive database queries. Database being like the MySQL in this particular case. Meta have warm storage as its data store. We have been looking at the various aspects here, from trying to serve all the metadata related to files from the flash to all the way to generating manifest files to reduce number of trips to the warm storage and saving on the network cost. The results from these improvements have been phenomenal. Permissions, lots of improvement have been done in this stack to improve the architecture. Before we used to make high number of calls for each tables and the columns from the ACL checking permissions, ACL checking perspective. And now we have simplified this architecture and just make like one single call to validate all the permissions related to a query. which has been huge saving. Last but not the least, data placement. Data placement at the meta scale is a huge challenge. With the extraordinary of the growth, it is no longer possible to fit schema or namespace in a single region, which means the schema becomes like a logical concept, and the tables are constantly moved across different regions to balance various factors such as networks and sizes, etc. So designing the queries with the data localities in mind is a challenge, as tables can be moved anytime. How did we solve this problem? We built basically interactivity at the core in the data placement algorithms, uh, along with trying to balance network and storage regions. It also prioritizes interactivity while trying to balance various regions. Sometimes it came with the solutions like tabling the table clusters together. Sometimes it came with replicating tables to reduce various storage cost. Now let's talk about some of the improvements we have done in the Presto to provide amazing latencies, right? The first is the Prestosimo. With the help of vlogs, we have been able to achieve like 2x to 10x improvements in the query latencies. We have done lots of work to build distributed caching for metadata and data to avoid various I/O calls, and that has been proven to be really impactful in terms of getting better latencies. We have improved scheduling between for the task scheduling with the event loops by and like in from the task from the thread based scheduling, and that has helped in removing various contentions with the logs and all, and has been hugely impactful and in reducing almost 90% in CPU from in the Presto scheduling component. We have also built linear and faster communication between coordinator and worker by leveraging thrift, moving away from JSON. We have been also building leveraging multiplexing with HTTP2. That has been huge help in reducing the SSL handshaking cost and things like that. We are also building IO optimization service to produce better data layouts. File compacting files is one of such examples, like where we have seen like various cases where a partition have like huge number of files for a small amount of data, which has been turned out to be expensive when it comes to dealing with like so many files and then so many splits. So compacting those files to reduce number of files and the split has been valuable. We also built very effective result caching, where for the duplicate queries, these results are served from the result caching. Hence, not just providing like much better experience to the users, but also reducing lots of load on the Presto computation. Cool. So with all the amazing improvements, both in the Presto and in the warehouse, we have been able to achieve really good improvements to the query latencies for various interactive use cases. However, the latencies at the tail, the P99 and beyond, remains a challenge. With the distributed nature of Presto, along with various dependencies, tail latencies remains volatile and not consistent. For example, in order to achieve P99 or more, we would need really high percentile guarantees from dependencies such as Metastore and warm storage. As for a single queries, we make tens of hundreds of interactions with Metastore and hundreds and thousands of interactions with the data store for reading metadata and data. So in order to achieve P99.9 from Presto, we would need even higher percentile from our dependencies. And these dependencies have various other dependencies, so it makes a complex web of dependencies, making it a gigantic exercise, almost impossible to be able to hit really high latencies. So in order to provide tail latencies 999 or 49, we needed to innovate. So before we dig deeper into how we innovated, let's first talk about how industry trend has been changing, especially in the hardware domain. So if you see like over the last 10 year or so, the availability of the much hardware has been there. Hardware envelope has shifted dramatically. If you think about like the network used to be significantly slower, used to be in 10 gigabytes per NIC or things like that. Now it's much, much better. Similarly, on the number of single socket threads, it used to be around 16 or 32. Similarly, on the memories and SSDs have been much, much cheaper on the newer machines. So the TLDR is like the single socket server now has more CPU network and memory than it was like 10 years back on a 10 to 20 node cluster. So how did we build the consistent and low latencies experience, right? So let's talk about some of the principles which we have leveraged to build this. Locality and parallelism is the key for amazing performance. And when you add like the efficient execution to these, like you have key ingredients. Having the data local to the execution can do wonders. And as we discussed, the modern hardwares are amazing. So you're looking like able to leverage fully these amazing machines can provide maximum performance. A lot of research says like the storage encodings and the compression can provide really good performance when it comes to accessing the data, right? Decompression speed can be 30 to 60 times faster depending on the implementation. Uh, let's understand like the encoding and compression a little bit better. So encoding is basically like the optimized physical representation of the data that exploits data characteristic to improve the processing speed. While on the compression remains like a black box and which helps with the data reduction, especially you are going with the network. So in short, the optimized storage really helps. So based on these principles and the hardware's availability, what we have looked towards like building like a single node offering, which has no RPC, which has its local data store to get data locality concepts. It is affordable because it is based on the single node, so minimum capacity is needed. Uh, with this and like all the amazing improvements in terms of like the storage, encoding, and compression, we have been able to uh, build the single node offering, which is able to provide really good performance um, consistently and reliably. This work is in the early stage, so we will share more details on this future. But with this offering, we are able to make some of the use cases work really well. I wanted to share a little bit more on the storage improvements we have done, especially part of this offering. So we have built various encodings to achieve some amazing performance, such as like bit packing to leveraging fewer bits to store integers. We have also built ALP, which is like the adaptive lossless floating point comparison, and that has been really helpful. We have also built various shared dictionary uh, to leverage good results. And so, as you can see, like these charts, which has been performed on the TPCH SF100, where we are using leveraging like the Velox vector to store. And when you see like these compression and the storage size have dramatically reduced um, in sizes and also provided like the amazing decompression speed, which has been hugely helpful in order to provide good experiences. So in this chart, like we have compared our storage versus Arc versus Snappy, and we have built various algorithms. So this shows like our um, work in which we have done. So if you see like the left one is like the uncompressed, like we were at this point like almost like 8 times than the org file format storage. and then basically we made like bunch of improvement. We improved like how we are copying this data into our own storage. We built like the shared dictionary. We built the standard. We did some general purpose compression on some of these columns. We built ALP algorithms, and all in all, like at this point, we are almost around less than 2x when it comes to like the general purpose compression, but it has allowed us to achieve really good performance when it comes to decompression and query performance improvements. Another use case which I wanted to touch a little bit on, this is called real-time analytics. So here with the real-time analytics, which is powering some of the critical ads analytics use cases in the Meta. Uh, Here, we not only have challenges to fast ingest the data because this data is generated by the real-time events, but also have the challenges related to like the really, really high QPS. These use cases run into thousands of QPS and while doing like the meaningful work in each of these queries. Uh, so each of these queries is doing like lots of processing, but we also need to serve thousands of QPS. So how we can solve some of these challenges, right? So I think the answer remains pretty simple, right? We are continuous to look towards making query execution lean and efficient from various angles, and that would be our path to be able to serve these really high QPS use cases, along with all the improvements and the infrastructure which we talked about. Conclusion. Uh, so Presto have made tremendous progress in enhancing interactive experiences at Meta, which is fueling lots and lots of critical use cases as we talked about. And the new challenges with these agentic exploration and the real-time metrics continue to pose multiple challenges in front of us and fuel innovation in in this cycle. Um, could not have been more excited in solving these challenges, and let's see how this shape the journey of Presto and the interactive warehouse at Meta. Thank you.